Getting I in the denominator means that fraction is not in the simplest form. But how to get the fraction in the simplest form? As you see here in this example, put each of the following in the form a plus bi, where a and b are real numbers. 4 minus 5i divided by 7i. You just have here imaginary part, which is 7i. So to get rid of I here, just multiply by I over I, because I times I is negative 1. So you get rid of the denominator by multiplying by I over I. And I over I is equal to 1. You remember? So I over I, which is 1, that means you didn't do anything. It's just the same fraction. So 4 minus 5i divided by 7i multiplied by I over I. You distribute I. So 4 times I is 4i, and negative 5i times I is negative 5i squared. That's in the numerator. And in the denominator, you have 7i times I, which is 7i squared. 4i minus 5i squared, I squared is equal to negative 1. So negative 5 times negative 1 is positive 5. And in the denominator, you have 7i squared, and I squared is negative 1. 7 times negative 1 is negative 7. And 4i divided by negative 7, because you will divide each term in the numerator by the denominator. So 4i divided by negative 7, and 5 divided also by negative 7. 4i divided by negative 7 is negative 4 over 7i, and 5 over negative 7 means negative 5 over 7. But to put that in the form a plus bi, you start with the real number first, which is negative 5 over 7, and then the imaginary part, which is negative 4 over 7i. That is the answer. Twenty-six divided by 3 minus 2i. Here in this example, you have the complex number in the denominator. You have the two parts, the real part and the imaginary part. So you can't multiply by I over I here, because if you multiply by I in the denominator, you will not get rid of I, because I will be distributed in both real part and the imaginary part. So if you get rid of I in the imaginary part, you will have I in the real part. So it's better here to multiply by the conjugate of the denominator. But what if the conjugate? Let's take an example of the conjugate. If you have 2 plus I, the conjugate of this number is 2 minus I. You just change the sign of the real of the imaginary part, I mean. You just change the sign. If the imaginary part is positive, in the conjugate will be negative, and if it's negative, will be positive. 3 minus 5i, the conjugate of 3 minus 5i is just 3 plus 5i, changing the sign of the imaginary part. 10i minus 6, here you have the imaginary part first and then the real part. So changing the sign of the imaginary part, which is 10i, it becomes negative 10i, and the real part will be the same, negative 6. If you have 15, it's just a real part here, so no changing the sign. It's just 15, the same. Negative 7i, this is an imaginary part, so just change the sign of the imaginary part, it becomes 7i. So here in this denominator, 3 minus 2i, the conjugate of this number is 3 plus 2i. So multiply the numerator and the denominator by 3 plus 2i. You have 26 multiplied by 3 plus 2i in the numerator, I mean. And I didn't distribute the 26 because I want to see the answer of the denominator first. Maybe, it's just maybe, you can simplify the 26 with the denominator. And to multiply the number by its conjugate, you just multiply the first term by the first term and the second term by the second term. So 3 times 3 is 9, and negative 2i times 2i is negative 4i squared. Now you have 26 multiplied by 3 plus 2i in the numerator, and in the denominator, I squared is equal to negative 1. So negative 4 times negative 1 is positive 4. So 9 plus 4 is 13. Now you can simplify 26 with 13. 26 over 13 is 2. So you have 2 outside of the parentheses of 3 plus 2i. Distribute the 2. 2 times 3 is 6. And 2 times 2i is 4i. That is the answer. 3 plus 2i multiplied by 2 minus I all over 3 plus I. Here, before multiplying by the conjugate, you need to multiply the first parentheses by the second parentheses, 3 plus 2i multiplied by 2 minus I, just making that change. So 3 times 2, you'll distribute the 3, and then you'll distribute 2i. 3 times 2, and then 3 times negative I. 3 times 2 is 6, and 3 times negative I is negative 3i. And here, 2i times 2 is 4i, and 2i times negative I is negative 2i squared. You have the like terms here. Negative 3i plus 4i is positive I, and keep 6 as it is. And negative 2 times I squared means negative 2 times negative 1, and means plus 2. So 6 plus 2 is 8. 8 plus I all over 3 plus I. Now you can multiply by the conjugate of the denominator, which is 3 minus I. So multiplied by 3 minus I in the numerator and 3 minus I in the denominator. And if you start with the denominator, 3 times 3 is 9. And I times negative I is negative I squared, because with the conjugates, you multiply the first by the first and the second by the second. And here, 8 times 3 is 24, and 8 times negative I is negative 8i. And go back and multiply I by the second parentheses. I times 3 is 3i, and I times negative I is negative I squared. Again, you have like terms, negative 8i and 3i, so it's negative 5i, and you have 24 first. And negative I squared means negative times negative 1, which is positive 1. The real parts here are 24 and 1, which is 25, minus 5i divided by 10. So the final part here is dividing each term in the numerator by the denominator, 25 over 10, and negative 5i over 10, which is 5 over 2 minus 1 over 2i. That is the answer. Find the values of x and y that satisfy each of the following equations. 10 over 2 plus I is equal to x plus y. Here in the left-hand side, it's not in the simplest form. To simplify that, you have to multiply the numerator and the denominator by the conjugate of the denominator, which is 2 minus I. So multiplying by 2 minus I in the numerator and 2 minus I in the denominator. Let's start with the denominator. 2 times 2 is 4, and I times negative I is negative I squared. And in the numerator, we have 10 multiplied by 2 minus I. I'm just keeping 10 outside of the parentheses until we see the answer in the denominator. Because maybe you can simplify the 10 with the answer of the denominator. So in the denominator, 4 minus I squared is 4 minus negative 1, which is 4 plus 1. That means 5. So we have 10 over 5, which is 2, times 2 minus I, which is 4 minus 2i. So again, you have 4 minus 2i in the left-hand side, and in the right-hand side, you have x plus yi. And as long as they are equal, that means the real part is equal to the real part, and the imaginary part is equal to the imaginary part. I mean, x is equal to 4, and the imaginary part, y is equal to negative 2. If x is equal to 13 divided by 5 minus I, and y is equal to 3 plus 2i divided by 1 minus or 1 plus I. Prove that x and y are two conjugate numbers. To prove that, we can simplify the two numbers, x and y. Let's start with x. X is equal to 13 divided by 5 minus I, and to simplify that, you have to multiply by the conjugate of the denominator, which is 5 plus I. So multiplying by 5 plus I over 5 plus I. So it's equal to 13 multiplied by 5 plus I in the numerator. And in the denominator, because they are conjugates, you can multiply the first term by the first term and the second term by the second term. 5 times 5 is negative or is equal to 25, and negative I times I is negative I squared. All right, so you have 13 times 5 plus I in the numerator again, and 25 minus I squared means 25 minus negative 1, which is 26. All right, now 13 and 26 you can simplify. They are divisible by 13. So 13 divided by 13 is 1, and 26 divided by 13 is 2. Now we have 5 plus I over 2, which is 5 over 2 plus 1 over 2 I. That is the first x, the first number, which is x. Let's start with y now. You have 3 plus 2i all over 1 plus I, and the conjugate of the denominator is 1 minus I. Just changing the sign of the imaginary part. Now here, because they are complex numbers in the numerator, you can distribute each number in the first parenthesis, 3 times 1 and 3 times negative I, and then go back to multiply 2i by 1 and 2i by negative I. 3 times 1 is 3, and 3 times negative I is negative 3i. And then 2i times 1 is 2i. And 2i times negative I is negative 2i squared all over 1, because 1 times 1 is 1. And I times negative I is negative I squared. In the numerator, we have like terms. Negative 3i plus 2i is negative I. And negative 2i squared means negative 2 times negative 1, which is 2. All over 1 minus I squared means 1 minus negative 1, which is 2. So again, in the numerator, you have like terms. The real parts are 3 and 2. 3 plus 2 is 5, minus I divided by 2. So you just have real part here in the denominator. You can divide each term in the numerator by the denominator. So it's 5 over 2 minus 1 over 2i. If you notice here, x is equal to 5 over 2, and here in y, the real part also is 5 over 2. So they are the same. They are the same in the real parts. But the imaginary parts are different in just the sign. So here you have 1 over 2i in x, and in y you have negative 1 over 2i. So they are conjugate. So they are conjugate numbers. If a plus bi is equal to 2 plus I divided by 2 minus I, prove that a squared plus b squared is equal to 1. Now, in the left-hand side, you have a plus bi, and in the right-hand side, you have 2 plus I all over 2 minus I, but it's not in the simplest form. And to simplify that, you have to multiply the numerator and the denominator by the conjugate of the denominator, which is 2 plus I. So multiplying by 2 plus I in the numerator and 2 plus I in the denominator. In the numerator, you multiply, you distribute the 2 and the I. So 2 times 2 is 4, and 2 times I is 2I. And I times 2 is 2I, and I times I is I squared. And in the denominator, you have 2 times 2, the first by the first, and the second by the second, because they are conjugates. So 2 times 2 is 4, and negative I times I is negative I squared. Let's go back to the numerator. You have like terms here. You have 2i and 2i. So they are 4i. And I squared is equal to -1, of course, divided by 4 minus I squared, which is 4 minus -1, which is 5. In the numerator, you have 4 minus 1, which is 3 plus 4i divided by 5. So the answer is 3 over 5 plus 4 over 5i. Now, what are a and b? A is the real part, and b is the imaginary part. So a is equal to 3 over 5, and b is equal to 4 over 5. All right. So the left-hand side in, in the question is a squared plus b squared. So 3 over 5 all to the power of 2 plus 4 over 5 all to the power of 2. So it's equal to 9 over 25 plus 16 over 25, which is equal to 25 over 25, which is equal to 1. And that is equal to the right-hand side. The conjugate of the number 1 minus or I minus I squared is 1 minus I, 1 plus I, or negative I minus 1, or I minus 1. Before getting the conjugate of the number, you need to simplify the expression I minus I squared, because I squared is equal to -1. So I minus -1, or I plus 1. So it's equal to 1 plus I by getting the real part first and the imaginary part second. So it's 1 plus I. So what is the conjugate of this number? You just change the sign of the imaginary part. So it's 1 minus I instead of 1 plus I. So the conjugate is 1 minus I. The conjugate of the number -8 is 8i, -8i, -8, or 8. This number is just a real part, so there is no imaginary part here. So the conjugate will be the same because there is no imaginary part to change the sign of it. So it's the same, -8. If z1 is the conjugate of the number z2, then z1, z2 plus z1 plus z2 is equal to a real number, an imaginary number, complex, not real, undetermined. Let's suppose that z1 is equal to a plus bi, the form of the complex number. Then z2 is equal to a minus bi because they are conjugate numbers. We just change the sign of the imaginary part, bi, negative bi. So the expression here is z1, z2 plus z1 plus z2. z1, z2 means you multiply the first number by the second number. And you remember, because they are conjugate, you just multiply the first term by the first term and the second term by the second term. A times a is equal to a squared, and bi times negative bi is negative bi squared, which is plus b squared, plus z1, which is a plus bi, plus z2, which is a minus bi. Now you have bi and negative bi, so they cancel each other out. So the answer is a squared plus b squared plus a, and that's all a real number. There is no imaginary part here, so the answer will be a real number.